Okay, so in section 2.6, we are going to learn how to combine functions in some different ways. Some of them are going to be more obvious than others. So I want to kind of introduce domain. I know we've already talked about it. I know we've talked about it as it's the values, the x values that we have. But I want you to maybe think of it a little bit differently. It's also basically what is x allowed to be. In other words, what am I allowed to plug in for x? And generally speaking, the answer is whatever I want to. Okay? Except for we have to make sure we don't break some of the big algebra rules. So we've been learning in math for a long time that we can't divide by what kind of number? What can you not have in the denominator ever?
0.
Yeah, so we can't divide by 0. In other words, no 0 in the denominator. So x is allowed to be anything except for something that would make that happen. Okay, we can't divide by 0. And you also can't take the square roots of negative numbers because you get imaginary results. So luckily for us, we're not concerned about imaginary results. We're more concerned with what could be graphed and what real tangible results we can have. Okay. All right, so we have to worry about these two rules for now. Later on in the semester, we'll introduce some new rules that we have to worry about breaking. But for now, these are it. So we have a group of functions that are called polynomials. Okay, so poly, the prefix means many, right? If you are a polytheistic religion, you believe in many gods. If you're a polygamist, you have many wives, right? So poly means many, okay? So polynomials is just the word that covers like lots of different things, okay? This is a polynomial because it's got two terms, okay? But so is this. X squared plus 4x minus 3 is also a polynomial. But so is this. X cubed plus 4 is a polynomial. Okay? So polynomials, if you want a description, they just have positive whole number exponents. The power can be anything as long as it's a positive whole number. So the point I'm trying to make is there's a lot of things that fall under the category of polynomials. Okay, x to the first power, x squared, x cubed, but even like x to the 10th falls under a polynomial also. Okay. When you have a polynomial, you really don't need to focus on the domain that much. Because remember I said that the domain is what is x allowed to be. Notice in these polynomials, we don't have to worry about dividing by 0, right? Because there's no fractions. We don't have to worry about a negative under a square root because there's no square roots. So if you don't think we have to worry about the domain, what do you guess the domain's going to be then? Negative infinity to infinity, okay? In other words, there are no restrictions on what x can be. So if there's no restrictions, then it's open, okay? X could be anything I want. If I wanted to, I could plug in 1,000,000 in for x if I really wanted to, okay? I probably wouldn't want to because this would be ginormous, but I'm just saying I could, okay? There's really nothing off limits for me. I could plug in anything. Okay, but when that becomes a problem is maybe when we don't have a polynomial. Okay, so if you see a polynomial, you can just be like, oh, the domain's negative infinity to infinity. I don't have any worries. But what about for this thing that is not a polynomial? Okay, because it isn't. It's a fraction with x in the bottom, so it wouldn't be considered a polynomial. We're actually going to talk about these types of functions this semester. Okay, but for now, I'm really just asking you one thing. I'm asking you what is x allowed to be versus what is it not allowed to be. Okay, so what do we not want to happen? We don't want the x plus 5 to be what in the end? We don't want x plus 5 to be 0, so I'm just going to use this not equal to 0 terminology. So most of you can probably eyeball and tell what would give me 0, But if you subtract 5 from both sides, notice that x can't be what? Well, 5 would be okay, but what kind of 5 is not okay? Negative 5, right? Because 5 would just give us 10. That wouldn't be a problem, okay? So the problem comes with how am I going to say this, though? Because remember, x can't be negative 5, but what can x be in general? Anything else. This is the no-no. Everything else is fine, okay? So if I look on kind of a flat number line, I want to kick out the one that's not allowed, but I want to include everything that's smaller and I want to include everything that's bigger, okay? So we're going to use interval notation. And I think the picture of that number line, especially if you're a more visual learner, helps you get where you need to go, okay? So if I was going to look at this number line and try to say that in interval notation, okay, where would I go back to the left if I go from left to right? I go back forever. So how do I say back forever? Negative infinity, okay? And then I want to make a stop at negative 5, right? Because I don't want to include negative 5. So how do I not include negative 5? What symbol do I use that says don't include it? Okay, parentheses as opposed to what's the other version I could use? A bracket, right? A bracket would mean yes, include it. What does a parentheses mean? Don't include it, okay? And then I have a union symbol because I have a second section. So then I want to start at negative 5, again not including it, but then how far do I want to travel eventually? All the way to what? Positive infinity? Okay, so this is literally how we write the interval notation of x can't be negative 5. Because we're more focused on what x can be, right? X can be anything between negative infinity and negative 5, just don't include negative 5. And then anything from negative 5 to infinity, just again, don't include negative 5. Okay, so what about one like this? And I think as you do a couple of these, you can probably eyeball what the off-limits values are. But my question is going to be, can you write it in the proper format? So what if you had this kind of sum of two fractions here? So I feel like most of us can kind of look and say what the off-limits values are, right? What's going to be off-limits here? What is x not going to want to be? 7. How come it can't be 7? Because if it's 7, what do we get in the bottom that's the no-no? We get 0, right? So 7 minus 7, 0, we can't have that, okay? What about in the second fraction? What can't x be for that guy? 5. So this isn't my answer because this is telling me what I'm not allowed to have, right? I'm really trying to focus on what I am allowed to have. So if I take a couple seconds to draw a picture, make sure you draw 5 to the left of 7, right, because it's smaller. So I want to kick out 5 and 7, but I want everything this way, everything in between, and then everything that way, okay? So I don't require the picture, but can you see how the picture can help you get the interval notation in the end? Because it even tells you how many sections long it needs to be, right? Like how many sections does this domain need to be? 3 sections long, okay? So we're going to go from negative infinity to what? First stopping point if we look at our picture. 5, don't include it, right? And then we need to go from what to what? 5 to 7, good, don't include either one, right? And then finally, for the last section, I go from 7 to what? Positive infinity, okay? So what I'm wanting is what I'm circling. I think the graph helps you get where you need to go in the end. So I'm going to say the graph is optional, but strongly recommended. Okay, so that covers when we don't want the denominator to be 0. But what about what we want to happen as far as square roots go? Okay, so what kind of numbers do we want to have with square roots? We want to have positive numbers. Okay, that's not just a hashtag in math, it means number. So we need to think about what this means. Positive numbers are numbers that are greater than or equal to 0. Okay, like 1, like 2, like 3, like 100. We don't want negative numbers, right? So that's actually how we're going to set up all square root problems. So if I ask you to find the domain of f of x equals absolute value of 3 minus x. So again, let's talk about it. What do I want to have? Let's focus on what I want rather than what I don't want. I want this whole thing to be what? I want it to be positive. In other words, I want it to be greater than or equal to 0. Okay? I can take the square root of 0. I just can't take square roots of things like -1 and -2. Those give me imaginary results. So this is how you're going to set up every single one of the root problems. Okay? You're just going to say 3 minus x, whatever's under the square root, greater than or equal to 0. Because that's how we mathematically say, hey, we want this to be positive. So if I'm going to solve for x, I need to subtract 3 from both sides. So remember, everything keeps the sign that's in front of it, right? So I actually have a negative x, but I don't really want a negative x. What do I want? I want positive x. So one way to get rid of that would be to divide by a negative. Okay? Part of this is on your competency exam, and I think we might have looked at this in some other way this semester, maybe not. But what happens to the greater than sign when you divide by a negative? It flips to be less than, in this case. So x is less than 3. So I'm going to circle that, but that's not really how I want my answer as far as format goes. But I think a number line can equally help us here. So how can I draw things that are less than or equal to 3? Well, first thing is, I do want to include 3. So I'm going to use like a solid circle there, like 3 is okay. And then I want everything to the which direction of 3 then, if it's less than? Everything to the right is okay. Everything to the left is not okay, right? So when it comes to finding the domain, again, I think the picture helps us get there. So what does my picture show the domain is then if I go from left to right? Negative infinity to 3, but here's how it's different. We want to use a what instead of a parentheses this time? Bracket, because why? We're including 3. 3 is okay. Okay. By the way, you can check your work and kind of see if it works out or not. So let's check a couple of numbers. Okay. For instance, let's check 3. If you plug in 3, then you get square root of 3 minus 3, square root of 0. Fine, no problem, right? What's something that's right to the left of 3? Like what would be right here? 2. Okay, so let's plug in 2. 3 minus 2 is 1, square root of 1, easy peasy, right? I can do that, okay? But what happens when you come over here, which is where we're not supposed to be? Like what would be right here? 4, and then you're going to get 3 minus 4, which is a what kind of number? -1, and that becomes a problem, right? So you can kind of check your work just by kind of mentally plugging in some of the values to see if it works or not, okay? But that ends up being my answer. All right, so what about this last one? So again, I want you to find the domain. But this time the function is going to have maybe more than one issue to keep straight. So what about if h of x is the square root of x minus 2 over x minus 5?
We have like 3 other domains, right?
I don't know about how many sections, but we have 2 rules we're worried about breaking, right? What are the 2 rules we're worried about breaking? Well, we don't want the denominator to be what? 0, so I'm going to start there because I think that's the most easy one to eyeball, right? So x cannot be what? What would make the denominator 0 so it's going to be off limits for us? X can't be 5 since the denominator shouldn't be 0. Okay? But also there's a second element which some of you kind of noticed already, right? What's the second thing I want to make sure doesn't happen? I want to only take square roots of what kind of numbers? Positive. So I want to set x minus 2 greater than or equal to 0. Okay, that is always how you handle square roots. Whatever's under the root, just set it greater than or equal to 0. Notice this one's even nicer than the one before though, because I don't have to worry about the dividing by -1 thing. What do I get? I just get x is greater than or equal to 2. So somehow I've got to include this and this in my graph. Okay? And I think if we just do it baby steps at a time, I think we can get there. So I'm going to mark 2 and I'm going to mark 5. You don't need a whole lot of detail to your number line. You just need to mark the points that are in question. So what do I know about 5? I don't want 5. 5's out. Okay, but what about 2? Actually, 2's okay, and actually anything what compared to 2? Well, this is a greater than, right? So anything bigger than. So I'm going to include 2, and then I'm going to go this way. Okay, because it's greater than. So then it just becomes, can you read this graph and talk about it from left to right? Okay, so how do you read it from left to right? So we start at what number? 2. We include 2, right? When do we need to take a break because it's not allowed? 5. We got to take a break at 5, okay? Because we have to make sure we don't want to include it. But then we need to pick right back up at 5 and eventually head to what? Positive infinity. So I actually only have 2 sections here, okay? But I think the picture certainly helps me get there. So I don't want 0 on the bottom, and I don't want to take the square roots of negative numbers. Okay, so we've kind of been looking at specifically fractions and roots, but it turns out you can also combine some different functions in some various ways. We're going to begin these 4 ways today, and then we'll pick back up with it next class. So you are allowed to do the 4 main operations: add, subtract, multiply, and divide. But when you do, you need to be aware that the domain may change. So in other words, it's fine to do it, but just be aware that you might have a change in domain. Okay, so I promise this is not so bad. The only thing that you might have to pause and think about is maybe domain. So let's say that I give you these 2 functions. Okay, they are both linear. How do I know that? Well, that's how I know they're functions. So how do I know they're lines, though? The fact that they're what power of x? Just first power, right? If it were squared, it'd be a parabola or quadratic, right? So if it's first power, it's linear, okay? So let's say that I ask you to find f plus g, f minus g, f times g, and f divided by g, and I want you to tell me each domain. So it works very similar to probably what you would expect. So what do you think we're going to do with the functions f and g if I'm asking you for f plus g? We're going to add them, right? So you're going to take f, which is 2x plus 3, and you're going to add g, which is x minus 1. Okay. What kind of terms are we only allowed to combine?
Like.
Only like terms, right? So think about 2x plus another x would be how many x's? 3 x's, right? And then what about 3 take away 1? Plus 2. Okay, so I end up getting that. Okay. There is nothing fancy or anything going on with the domain, right? What's the domain when there's no issues? Negative infinity to infinity, okay? In other words, we don't have a denominator, right? We don't have a square root, so we don't need to worry about the domain issues on this one. Okay, so what about f minus g? So it's going to look just like the one above it, but we're going to do what with them? Take the 2 functions and subtract them, right? So people usually make little errors here, okay? But it's minus the whole g, which actually means that the minus sign needs to go to both things. Okay, so in other words, what's it going to do to both signs then? It's going to change them, right? So this one's going to be a minus, and that one's going to be a plus. But then we're still going to only combine what kind of terms in the end? Like terms. So 2x take away x would just be 1x. 3 plus 1 would be 4. Okay, so what would be the domain of this guy? Again, nothing fancy going on, so what's the understood domain then? negative infinity to infinity. That needs to probably be one of your go-to domains. If there's no problems, it's just going to be negative infinity to infinity. All right, so what about f times g? So 2x plus 3 times x minus 1. Okay, I can't maybe do this one quite as fast because I should know how to do this though. It's on our comp test. Okay, so how do I handle a two-part thing times a two-part thing? Yes. Okay, good job. FOIL is what we use, right? Which stands for first, outside, inside, last. So let's do FOIL. So 2x times x is a 2x squared. Outside would be 2x times a negative 1, which would be minus 2x. I for inside, 3 times x would be 3x. And then 3 times negative 1 is negative 3. So if I add like terms, I get 2x squared plus x minus 3, right? Because I combined the negative 2x plus 3x. But what's the domain of that still? Pretty uninteresting. What is it? Same thing, okay? Because there's nothing off limits about x, right? So it's just negative infinity to infinity.